ProcessView is an add-in to Microsoft Visio for business process analysis. ProcessView works with native Visio diagrams and seamlessly integrates Visio with Microsoft Office and SharePoint applications. ProcessView automatically configures flowcharts for analysis and is the only solution in industry with the ability to automatically deconstruct and analyze complex workflows. ProcessView implements the approach for modeling queues and congestion as pioneered by Hopp and Spearman in their revolutionary text, Factory Physics. ProcessView may be employed to analyze a single process or to perform comparative analysis between current and future state flows. ProcessView generates standardized, comprehensive analysis reports and management outbrief to quickly summarize analysis findings. Because ProcessView works with native Visio and does not require the use of any particular templates or stencils, you may begin working with existing diagrams immediately. In the alternative, a new map may always be created. Once the sequence of activities and decisions that make up a process are captured, shapes may be quickly configured to store process data using the Add Update Attributes button on the ProcessView toolbar. Before configuring a map with new attributes, ProcessView will first inspect the map for any issues that may hinder analysis. Any errors encountered will be presented to the user for review. Selection of an error message in the ProcessView dialog highlights the location of the structural issue, so repairs may be quickly and easily made. Once all errors and warnings have been addressed, ProcessView will automatically apply the shape data attributes necessary to describe the time, resources, and cost associated with the activities in our process. In order to analyze a process map using the ProcessView analysis engine, there are a few attributes that will need to be defined. To describe the work schedule and the type of process being analyzed, ProcessView applies what are called page or process properties. It is within the page properties that default time units and available work time are described. For this example, we will add a map title and define a 40-hour work week. To describe the pace of arriving demand, ProcessView adds the arrival rate attribute to each of the start nodes in the map. For our order process, we'll assume we process 45 orders each hour. For each of the activities in the flow diagram, ProcessView applies an attribute called duration to describe the elapsed time at an activity. The process time attribute is used to describe the amount of actual work time or manual time at an activity. A resources attribute allows us to define the human and machine resources involved in the process, and the stations and batch size attributes describe capacity. For the connectors in the process, an attribute called probability is used to describe the likelihood that a connector is traveled and is then used to calculate the frequency activities are performed. Finally, to incorporate resource cost, we'll use the defined costing rate list function on the ProcessView toolbar. This will compile a list of the resources involved in the process so we can easily describe the cost per hour associated with our operator and QA resources. Once attributes have been defined, information about process performance can be obtained by selecting the Analyze Process button on the ProcessView toolbar. The ProcessView analysis engine will scan the map for defects and present any appropriate errors and warning messages. If no issues are encountered, Excel is launched and the summary analysis report is written. This report allows us to obtain answers to fundamental questions like how much work is involved, how long does it take, and what is the cost associated with processing an order. Review of the map profile worksheet gives us a snapshot of process performance. Review of subsequent worksheets in this report provide a worst to best performers view for 4 fundamental performance indicators. The duration worksheet indicates that if the purpose of the analysis is to identify the greatest potential for a reduction in turnaround time, the order receipt activity should be the focus. As this activity contributes more than 60% of the average elapsed time to process an order, it presents the greatest potential for improvement. The process time worksheet directs our attention to the automated order activity. Of the 4¼ minutes of work required to process an order, the automated order activity contributes over 50% of this time and will therefore present the greatest opportunity for work reduction. The cost worksheet also directs our attention to the automated order activity. As it contributes some 45% of the average order processing cost, it will present the largest potential for a reduction in resource cost. Finally, the utilization worksheet confirms that the automated order activity should be the focus of improvement actions. At a utilization of 84%, this is the bottleneck of the order process and will therefore determine the demand level that can be reasonably supported. It's important to note that the custom order activity is at 75% utilization. This indicates that a shift in the mix of demand requiring a larger proportion of custom orders will have significant impact on the performance of our order process. Now that the current state model has been composed, future state models can be quickly created to analyze and understand how the process will perform under different demand or changed activity characteristics. With ProcessView, business process analysis is as easy as 1, 2, 3. Simply open an existing Visio diagram or create a new process map from scratch. Apply the ProcessView attributes and define values to describe the time, resources, and cost involved. Then, use the ProcessView analysis engine to obtain the information needed to understand and manage process performance.